What is a safe operation? What is idempotent? What are the 5 most common HTTP verbs? What are the difference between post, put, and patch? Let's talk about them. Hello and welcome to Code with Star. How are you doing today? Last time, we created 2 types of Web API together, a minimal Web API and a controller-based Web API. And during the process, we briefly mentioned there are 3 elements that is very important: HTTP method, route, and the response. And in this video, I want to go dive deep with you together into one of them, the HTTP methods. We're going to start by talking some of the theories. Then we'll write some code to practice it. And toward the end, we're going to look into how to test it. Let's get started. HTTP methods, sometimes also called HTTP verbs, are messages to the server about what type of action to take. If you search online, you're going to see a list of around 40 different verbs. We're going to focus on 5 common ones today, and I'll give you some perspectives about how to understand a verb so that you will be able to understand these methods in the future. For that, we will need to agree upon some terminologies. First, safe means it won't have impact on the target resource. For example, when you get the resource from a server, it won't change the resource itself. That we say the get operation is safe. On the contrast, delete is not safe because the target resource is going to be removed from the server. So delete is not a safe operation, right? What I want to call out here a little bit is that it is going against the target resource. For example, when you get some sensitive data from the server, there could be audit logs. That we say get has some side effect, but it's still safe. Second, idempotent. A verb guarantees idempotent if the effect of one request on the server and many requests on the server are the same. For example, the verb of delete. By deleting the resource once versus deleting it the second time, the effect is the same. Upon success, the resource is gone. So we say the verb of delete is idempotent. Is get idempotent? Of course it is. You call get once, twice, a third time, many times, it does not change anything on the server. So any verb that is safe, it is idempotent. And then what is not idempotent? Post is not. Let's assuming using post to create objects. You post it once, it creates one object. You post it the second time, it creates the second object. So every time you do the identical operation, it will change the resource on the server. In other words, you call it once versus you call it many times. They lead to different results. That's why we say post is not idempotent. Third, cacheable. In the video, we talked about RESTful API. We talked about cacheability. That is, a RESTful API will clearly identify whether the response is cacheable or not. So if it is cacheable, that means the response can be cached, and the client on the second request do not need to contact the server for the response. Here we go. Some of the response for these verbs are cacheable, and some of them are not. One thing to call out: when we say safe or idempotent, the object is the resource on the server. But when we're talking about caching, it's always the response. Now let's take a look at the table. We have 5 very common HTTP verbs listed. When we look at any verb, these are the 5 things to consider. Does the request have a body? Does the response have a body? Is it supposed to be safe? Is it idempotent? And is it cacheable? Now be very careful. These are styles, but they are not constraints. That means, technically, you could force it to behave differently than what is listed here. By doing that, you are still building a web API, but then it is not a RESTful API. In other words, if you are intended to build a RESTful API, you should not break these threads so that the various clients will have a reasonable expectation of how your API behaves. Okay, blah blah blah. What does it has to do with the API that I am building? Coming next, let me explain that. Let's start with a quick question. What are the services dealing with? The answer? Data. And there are 4 types of operations. They are CRUD, CRUD. C for create, R for read or retrieve, U for update, and D for delete. Whatever data we are dealing with, we are always doing these 4 operations. Think about the fish items in the fish card. Firstly, we create them, the C. Then we read them and display them on the website, the R. If we need to change the recommendation level, it's an update, the U. And finally, you want to remove an item, it's a delete, the D. And that is all, simple like that. And now, this is a magic moment. In the RESTful API video, we talked about uniform interface. Put it together with the 4 operations that we need for our data. And then map them to those 5 HTTP verbs. We now have a bridge in between the operations that we need and the RESTful API requirements. Yes, but wait, how does it work? Why is it 4 operations mapping to 5 verbs? Let's bring back the HTTP methods table and exercise a mapping on our own. First, let's get something simple out of the way. A delete maps to a delete. They are semantically the same, it's not safe, and deletable data is idempotent. Perfect match. Get verb for reading or retrieving. Well, when you read the data, you want it to be safe. The get verb is the only one that fits here. Get is also cacheable, which is ideal for getting data. And that leaves us create and update. Well, you might be told that post for creation and put and patch for update. That is okay for remembering. But if you really look into what's the difference in between post and put, post is not idempotent, and put is. Let's use an example to get more understanding. Assuming I want to add a new item to the fish card sets, this is how I'm going to do a post. Pay attention to the URL that I'm using. It's going to be the collection of the fish. Now on the server, what could happen? It takes in the body, creates a record for the fish of salmon, and generates a unique ID for it, and return the reference to the result. We're going to talk about more details later. But for now, imagine the post happened again. It will create another record on the server, so you see it. Posted once or twice leads to different results. Now let's see how put works. When you put an item, you don't usually put to collection. You put to a specific URI for an item. Why? Because if you would put it again, it's the same item. It would not lead to a second item on the server, and that satisfies the threads of idempotent. Of course, if you change anything, like for example the fish name, and put it again, it becomes an update. Now coming back to the initial question, which verb should we map for creation? I think it is a case by case. It really depends on what kind of behavior that you are looking for in your system. A rule of thumb is that if the server controls the ID, use post for creation. But if the system allows the client to decide an ID, you could choose from using post or put. I hope that explains it well. I'm sorry this is a complex situation. It is not a one-size-fits-all. Another frequent asked question, before we jump into the code, that we could use put for update or we could use patch for update. What's the difference? Well, this one is more semantic. Put is designed to do a full update, and patch is for partial. Let's take a look at another example. At the beginning, we have a fish named Salmon, recommendation 1, and it then has an edit times of 2. Assuming we want to update the recommendation from 1 to 2, if we do it with put, we would need to manually bump up the edit times from 2 to 3, because put requires a full object. You call it an update. I would treat it more like a replacement. Patch, on the other hand, allows you to specify partial parameters. Say patch the recommendation to 2, and the server would be responsible for 1, keep the fish name, 2, update the recommendation from 1 to 2, 3, bump up the edit times. That would be less traffic, but not idempotent. And those are the major differences in between a put and a patch verb. For some scenario, put works better. For the others, patch is better. And that's why we have 2 verbs for update operation. Alright, so many theories. Let's see how can we put them into use. Code with me, please. You're not going to get it if you don't do it by yourself. Let's start by checking the .NET SDK version installed on my box. First, to focus on the CRUD operation, as well as the verbs I'm going to use, I did some preparation to the code. Firstly, we have this fish item. This is a very simple object model that we're going to use to hold a fish record. It only has very basic information like an ID, fish name, and the recommendation level. Then I have an in-memory repository to save fish items. Well, imagine this to be your database, but very simplified. So let's do some coding. This is a controller-based API to expose an endpoint. The first thing that I'm going to do is I'm going to create a controller. And this is very easy to do. You just create a class. This class, like I mentioned earlier, need to inherit from controller base. We will need to attribute it as an API controller. We're going to have a route for it. Oh, by the way, I'm going to have another video to talk about routing. So let's not worry too much about that right now. What do we want? Let's start by creating an endpoint for read all the fish items. Now, reading is simple. We just apply HTTP Verb of get onto it. Since the data is in the repository, I'm going to inject it into our class. And this method is going to return all the fishes. Let me also throw in some logic to get one fish item. Okay, simple like that. Now let's talk about testing. For get, it is simple. You could punch in the endpoint in the browser, and it will display a result of empty. And of course it is empty because there's nothing in the repository, right? So let's see how to enable the creation of a fish. I'm going to use the same endpoint for creating a fish item. So I'm going to put the code in the same controller class. The difference in between this method and the get method, it is marked by this HTTP post attribute. So even though they are exposed through the same route, one handles get request The other handles post. Another difference is that we need a parameter to hold the information for the new fish. A common practice is for the client to submit an object in the body of the request. We'll see how is it used in the demo later. Let's finish building the code first. It's actually easy, just put a FromBody attribute to the parameter that you're going to use. And then, of course, we need to wire up the logic to save the new fish item. For a post operation, when it succeeded, we usually return the new item in the body of the response. Use the status code 201 created, and also in the response header, attach a location for the client to access the specific item. And here's how you do it. And we're going to verify that in a couple of minutes when we test it. To test a web API that uses a different verb other than get, we will need to leverage some tools. Some popular options like Postman, CRUD. If you like to use the VS Code, there's an extension named Thunder Client. They come in different forms, but at the end of the day, they are helping us to submit requests with the same information. Here I'm going to use the Postman for an example, and I'll point out what to watch so that you could apply it to a different tool that you are familiar with. Let's do a post request. We start by picking a verb, and let's choose post. Now the request URL, that's going to be our local host. And of course, you also need the proper port number. And then we need to put in the route or the path. And there could be URL parameters. We're going to talk more about that when we talk about routing. And for now, we want to attach a body to the request. We're going to use raw here. And here we could put in any text. I'm going to put in a JSON object. And that's pretty much it. Let's click the send and see the result. Let's inspect the response. The status code is displayed here. 201 created. The new item is in the body. Notice this one comes with the GUID that we didn't submit in the body. So we know it comes down from our backend. And let's see the location. And that is where to get the specific item. Now that we have one item in the repository, let's run the get again. Except that this time I'm not going to use the browser. I'm going to do it in the Postman as well. Hey, isn't that the item that we just created? Fun time. Let me go back to post the same item several more times. If you see it, you're going to believe it that the post verb doesn't guarantee idempotent. And whenever I do a post, it has impact on target resource, and there's going to be a new item. Okay, let's stop here. I hope this laid down a good enough fundamental for you to start your trip to understand HTTP verbs.
Nice.
I'm going to finish all 4 operations in code, and I'm going to share the code base with you. And here we go, CRUD versus get, post, put, patch, and delete. I hope you enjoyed the video. If you have reached this section of the video, give me a like, please. Keep coding, keep improving, and I'm going to see you in the next one. Until then, take care.